So, welcome to our second class on blockchain and its application course. So, in the last class we have talked about this concept of decentralization and how decentralization is interesting and what type of problem occurs in a decentralized marketplace. So, we have seen that in a decentralized architecture there are multiple different stakeholders who do not trust each other and they want to coordinate with each other. So, in this particular lecture we are going to see that how we can design a solution for a decentralized architecture, and from that perspective we are going to see that what is the idea of or how the idea of blockchain has been emerged from this concept of decentralized marketplace. So, let us start our journey in today's class, where we are going to see further about in the petroleum supply chain how we can effectively design or effectively implement a decentralized solution to solve the problem that we have mentioned. So, that is the different topics that we are going to cover today. The decentralization with a blockchain, the fundamental properties of a blockchain in that context, and finally, we are going to conclude our course today on formal definition of a blockchain. So, these are the keywords for today's topic. So, to start with, as we have seen in the last class that my primary requirement for having a successful supply chain is that I need to have a kind of strong coordination among different players that I have. So, individual players, as I have mentioned earlier, that they do not trust each other, but still if I can develop a solutions through which they can coordinate with each other, then that particular solution possibly gives them a kind of better view about the entire platform, entire business model, and that way they can possibly help themselves in growing further in their business. So, let us see that how we can design a decentralized solution for this particular problem, which we have seen in the case of petroleum supply chain in specific and supply chain in general. So, my problem is that I have multiple different players or multiple different stakeholders, and these stakeholders they want to coordinate with each other. Now, when these stakeholders want to coordinate with each other, the fundamental principle is that I need something where they can submit information, well, and then I would have a way to verify that information. Well, so for the time being, let us assume that I have a blackboard, assume that this blackboard has been provided by God. So, that way it is something like that everyone can get access to that blackboard, but at the same time whatever they are writing on that blackboard, that becomes permanent. Well, no one will be able to change that, and on that blackboard I am bringing up all the stakeholders who are there in the end to end supply chain. So, everything that is happening in this end to end supply chain, that is going to get logged or going to get recorded on this blackboard. So, that way whenever some crude oil is getting produced, then that corresponding stakeholder they put up an information on the blackboard saying that 12042 barrels produced on Mumbai High on December 26, 2020. Well, so after this production has happened, then comes the distributor. So, when the distributor is going to distribute this crude oil to different organizations or different crude oil storage, they put up an information saying that, well, 16,467 barrels transported from Mumbai High to HPCL refinery on December 26, 2020 at 2:30 p.m. Well, so that way whatever informations you are going to put on that blackboard, everyone can see that information, and that is interesting. Why that is interesting? Because just by looking into this entire information which is there in the blackboard, you can track that what is happening where. That means how much amount of crude oil has been produced, how much of that has been transported, and not only how much of that has been transported to where, and then from there where it got further transported, in which refinery it is going to, after refinery how much amount of different products like petrols and diesels that have been produced, and so on. Well, so that way you will have this entire information on the blackboard, and anyone, that means any of the stakeholders will be able to see it, and because I am going to keep a track of this entire end to end information, everyone will be able to verify it. Well, so for example, if you see that 100 barrels of crude oil has been produced, and after that 60 barrels have been transported to say refinery X, and 20 barrels have been transported to refinery oil. So, immediately you can ask the question that what happened to the remaining barrels. So, because you have just mentioned that I have 100 barrels that have been produced, out of that 40 and plus 20. So, 60 barrels have been transported. So, what happens to the remaining 40 barrels? Well, so that way you can actually do some kind of simple analysis on the information which is there on that blackboard, and immediately you can find out if there is some kind of discrepancies in this entire end to end supply chain. So, that is the kind of interesting stuffs here. Now, there are certain properties of this board that need to be maintained. So, the first property is that we are assuming that this board has infinite space. Well, so that means if you are writing something, you have space to write. Well, you do not need to erase the old information, and if you do not need to erase the old information and you have infinite amount of space to submit information, that means all the historical information is there on that board. Well, so that way, by looking into the historical information, anyone can verify that what has happened or whether certain discrepancies that have been observed or not. Well, and that way, so if you have heard of this term blockchain earlier, you possibly have heard of that blockchain has the power to understand, or blockchain has the power to find out different kind of fraudulent behaviors or different kind of corruption. Well, and this is the point, because I am going to find out a solution through which I am going to keep up the entire historical information, and if I am keep up that entire historical information from different place, anyone would be able to verify whether there is certain kind of discrepancies which is there or not. Well, so this is the kind of first property that the blackboard need to have. The second property of the blackboard is that everyone should be able to see this blackboard. Well, because I want to ensure verification. Well, I want to ensure that whatever information that is being made public, these are kind of transparent information. Anyone should be able to see the information and they should be able to verify the information. Well, so the third property that I need on this particular blackboard is that any change in information should be visible to everyone. Well, so that means it might happen that you have written something by mistake. Well, it can always happen. So, these are I am talking about the different organizations where human beings are working, and mistakes can happen with any human. So, you can write something by mistake. Now, even if you have written something by mistake, then if you want to change it, you are not allowed to erase it. What you can do, you can just mention that, hey, this point number 100 that I had written earlier, that I had written by mistake, and this is the correct information that I have. That way, everyone also have the information that this is the thing that you told earlier. Now, you are actually deviating from your view and you are saying something different. Well, so that information I would also like to make it transparent, so that everyone can see it and everyone should be able to verify it. Well, then my next requirement is that, or this is not rather a requirement, that rather a property of this board, that I mentioned that this board is not erasable. Well, so if something is written once in this board, no one will be able to erase it further. Now, if no one would be able to erase it, that gives a powerful application. That means, no one would be able to deny later on that I have not done this. Well, so if you remember that in the last class I mentioned that this is one of the major problem of any decentralized architecture. So, one of the possible solution that you can have was to have a kind of web portal where every organization is going to submit their information. But when every organization is going to submit their information to that web portal, it might happen that later on one organization may claim that, hey, I have not submitted that information, someone has impersonated me and they have submitted that information to this portal. Well, or this portal is in the hand of certain centralized person, so those person have made some fraudulent activities and they have changed my information. Well, so those kind of thing is not possible with this board. So whenever you are going to write something, after that you are going to put up your signature verifying that, hey, I have written this, well, and this information is permanent on the board. That way you will not be able to deny it later on. Well, so this is the kind of powerful property that I have for this board. Now let us see that how we can utilize this board further. Well, so the advantage here is that you can simply do a one-step auditing of the entire information. You do not need complex or manual checking of all the papers, get the papers from different organizations, verify that. Well, so that kind of complex task is not possible. Even a simple computer program can do the auditing for you by analyzing all this information that have been submitted to this board and saying that whether there is any kind of discrepancy in that information or not. Well, so that way it can automate the entire process. Well, and again from the perspective of the petroleum supply chain, by looking into this board, you can simply say that, well, this particular organization, say company X, has this much of additional barrels and I am now having lack of barrels of petrol. So, I need petrol, so I can possibly approach to this company to get additional petrol from them. Or say company Y is currently selling petrol at a lower price, so I can possibly approach them to get the petrol from them. Well, so we can actually do such kind of matchmaking by writing some kind of simple computer programs. Well, so that's that advantage you get if I can make all this information public and all this information verifiable. Well, but the problem which comes to us is that who is going to maintain this board? Well, because if you just think of this board looks pretty similar to the web portal that we have mentioned earlier. So, the only difference is that I am just putting up certain additional constraint on this board. Well, but someone has to maintain this board, and as I have mentioned that in my end-to-end supply chain architecture, I do not have any centralized coordinator who is coordinating this entire process. Well, so it might happen that, well, you can argue that, well, government is going to maintain that, but even if government is going to maintain that, there happens to be lot of debate. Well, so that we have seen earlier in different use cases, say for example, during the maintenance of the Aadhaar database. Well, so that is one of the prominent use case where you will see that government is providing certain service, they are maintaining a database, but then there is a lot of debate that what is the security of that database. I am providing my personal information to the Aadhaar, so what if that someone steal my information? So, all these different kind of questions come. Well, so we'll discuss later on, that is actually an interesting use case for blockchain as well. So, later on we will discuss that how we can solve this particular problem using blockchain. Well, but what I am going to say here that, well, if you just allow one centralized entity to maintain this blackboard, then that particular solution is not scalable. Well, so as I have mentioned that I want to have a kind of complete decentralization. I do not want to have a kind of central authority to maintain everything, because in that case if that central authority fails or certain attack, certain thing happens to that central authority, then all the information is lost, all the coordination is lost. Well, so a perfect decentralized system will actually help me to make the system more fail safe. Well, and then there is another fundamental principle behind that. Well, so that is again pretty much of interesting. So, for example, if you have a central point which is maintaining all the information, then it is easier to attack on that central point, because the attackers precisely know that where to do the attack. But if you are decentralizing the entire architecture, if you are saying that, well, no one is going to maintain this information solely, rather I am going to maintain that information in such a way so that multiple people is going to maintain that information. So, then it becomes difficult for an attacker to make certain changes on that information. Why? Because just think of it is in this way. So, you have a single person who is maintaining the information, and then what you have done, rather than a single person maintaining this information, you have 100 different persons who are maintaining the same information. Now, when 100 different persons are maintaining the same information and you are relying on some kind of majority among those 100, that means what the majority of those 100 information sources are saying, you are relying on that, then actually in the first case, when a single source is maintaining the information, the attacker only need to do an attack on that single source. But when you have 100 different sources and you are relying on the majority to validate certain information, then the attacker has to actually compromise at least 51 of those sources, so that the majority becomes compromised and they start giving the false information to you. Well, so that way decentralization always improve security. Well, so that is one aspect. Obviously, so as I have mentioned in my first class that there is no free lunch. Well, so that way even with decentralized you have certain overhead that we are going to discuss later on, but at least this is the kind of advantage that you get. So that way if I just say that, well, I will buy cloud from Amazon, we are not happy with that who is going to pay the money to Amazon, who is going to manage it. So those kind of questions come. Well, so I do not want to have such kind of third party who is going to maintain the information on behalf of me. Well, another possibility is that, well, one of the enterprises who are there in this entire supply chain that is going to maintain this information source. Again, I mean that is possibly a worst solution, because as I have mentioned that all these enterprises are competitor to each other. Because they are competitor to each other, then there is no guarantee that the person who is maintaining that information, that person is not a fraud. Well, so that kind of scenario can always happen. Well, finally, one possible solution that we can maintain here is that we can say that, well, let everyone maintain the same copy of the board individually and independently. What does it mean? That means rather than having a single copy of the board that is maintained by someone, I am making a decentralized architecture of that board. That means rather than a single entity or a single source maintaining that entire board, I am saying that, well, let every individual organization maintain that board. Well, so that way I can get a decentralized architecture. Well, we are happy with that, but immediately the next question comes that how I am going to enforce this particular decentralization, because this decentralization will bring up multiple different additional challenges. How? So, for example, the moment you are saying that I do not have a single blackboard which is containing all the information, rather everyone is going to maintain their own blackboard, the first question which is going to come, that what is the guarantee that everyone has the same information to their local board? Well, so that kind of challenges come. So, we need to find out a solution to solve this particular problem. So, this is my problem, that I have a blackboard, who is going to keep it, and I am saying that, well, rather than a single entity keeping this blackboard, let us build up a decentralized architecture of this blackboard, and every organization, every independent organization stored a copy of that blackboard. Well, this looks good, right, because in that case I have solved my original problem, that who is going to store the information, but I have landed up in a new problem. What is that problem? I need to have something, or I need to have a way to maintain that the information which is there in this individual board, they are consistent. Well, so my architecture says that no one is the sole owner of the data, but everyone has the copy of the data. So, I do not have any kind of central database, but I need to ensure that everyone holds exactly the same copy of the data at the same instance of time. So, it should not happen that this particular blackboard contains one information, whereas this blackboard contain a complete different information. Well, so I need to ensure that all these different blackboards which are there, they contain exactly the same information. Well, this is the kind of specific requirement which I have. Well, and we will see that there is some interesting architecture in our classical distributed system literature through which we can solve this problem. Well, so this is called a kind of what we say as the distributed consensus problem. Well, so later on we are going to see that what consensus means. Well, so then come my idea of converting these blackboards to what we call as the blockchain. Well, so what we are saying, now let us replace this blackboard with a particular data structure that is called a blockchain. So, what is a blockchain? A blockchain is an immutable, append only, ever growing chain of data. Well, data once added cannot be deleted or modified later. Now, here you see the individual things that I have mentioned, they actually replicate the property of the blackboard that I have mentioned earlier. Well, I am having a kind of immutable data structure. Well, so whenever I am saying that it is immutable, that means no one will be able to make any change. Well, so that is the thing I am going to support. Then I am going to say that it is append only. Well, so append only basically means that you cannot erase. So once you have written something, then that thing cannot be deleted any further, and then because it is append only, it is also ever growing. That means as you are going to add up new information, additional information source or additional blocks, what we call it, that will be get appended to this blockchain. Well, and finally, data once added cannot be deleted or modified later. Well, so these are the property that I am going to support in this particular data structure, or through which I am going to mimic the concept of blackboard that I have mentioned earlier. So the things works in this way. So every individual player, they maintain their copy of the blockchain. So here I have one copy of the blockchain for this particular organization. This organization, which is possibly a refinery, that organization maintains its own copy of the blockchain. Then the distributors who are there, they maintain their own copy of the blockchain. So that way everyone is maintaining their own copy of the blockchain. Well, and they process the data locally. So that way whenever you need to find out something, you just do a local processing on that data source and find out the answer to your question. Well, now why we call it as a blockchain? Well, so you can just think of it in from this particular structure which is being shown here. Well, so whenever you are going to add new information, the way we are going to add new information to the existing blockchain is in the form of block. That means I am forming a block of information and then going to apply certain technique to append this block with an existing blockchain. Now, whenever I am appending this block with an existing blockchain, I am ensuring that the same block is going to get appended to all the local copy of the blockchain. Well, so that is the requirement which I am going to support here. So that way we see that the entire data structure which I have, it is basically a chain of blocks. Well, because it is basically a chain of blocks, we call it as a blockchain. Well, from this particular way the terminology actually got designed, or the terminology arrived. Well, now this blockchain, the protocol or the kind of backend architecture that we are going to design, we are going to discuss that what is that in later classes. It will actually ensure that every party has the same view of the blockchain all the time. Well, so everyone can get a common view of the blockchain. So that way the information which I have in the blockchain, it is transparent to everyone. So that way, just like the concept of blackboard that I mentioned earlier, everyone can verify and validate the information by looking into the historical information in its local copy of the blockchain. Well, so this is the kind of broad idea about blockchain. Well, so in the context of an use case, and later on we are going to learn about what are this block comprises of, what are the content of this block, how will you form this chain, well, and then most importantly how will you ensure that every individual party has the same copy of the blockchain, same copy of the information, well, they do not deviate from each other. So that is one of the primary objective or primary thing that I need to ensure. Well, so finally just to conclude, let me try to tell you a kind of formal definition of blockchain. So I can call blockchain as a decentralized immutable append only public ledger. Why it is a public ledger? Because here everyone is going to maintain their own copy of the blockchain, and whatever information they want to log in the blockchain, they do it publicly. Well, so everyone can see it. So that way we call it as a public ledger. Then it is obviously decentralized, everyone is maintaining their own copy, it is immutable, that means you cannot make any change to the existing change. What you can do, you can only append additional data, so that is why it is append only. Well, so this particular formal definition of blockchain, it actually captures all its property, the primary properties of a blockchain, which is decentralization, immutability, append only nature, and public information. Well, so these 4 keywords, decentralized, immutable, append only and public, they actually tells you the entire property that a blockchain supports. So, in conclusion, we got a kind of broad idea of blockchain and its possible use cases, and here the use case that we have seen, it is not a cryptocurrency application. As I mentioned in the first class that we are going to look into cryptocurrencies later on, but I have started with an application that is a non-cryptocurrency application where blockchain can provide significant benefit in terms of business. Well, and that way you will see that in the enterprise use cases, blockchain actually provide a lot of different application primitives that someone can use to make such kind of open marketplace more effective and more performant. And next we are going to learn about certain fundamental cryptographic techniques which are used to design in a blockchain. So, in the next class Professor Shural is going to continue with these fundamental cryptographic techniques, and then we will come back with the broad design of a blockchain and how the blocks look like, how the chains look like, and what forms a end-to-end blockchain structure. So, that is all for today's class. Thank you all for attending. Hope to see you all in the next class.